I, Jv'n Neha Sharma, JVWU Women's University, Department of Science and Technology, Faculty of Education and Methodology. So our today's topic is TCP/IP protocols. Right? In last lecture, we studied about OSI model, right? Open System Interface model, and in this lecture, we studied TCP/IP protocol. Basically, this is conversion or to say the compressed model of OSI model because in OSI model there are 7 layers and in TCP/IP protocol there are only 4 layers, right? So TCP/IP protocol, what's the full name of TCP/IP? So TCP stands here for Transmission Control Protocol and IP is for Internet Protocol. So there are 4 layers only in this TCP/IP protocol suite. First one is process application layer, second is host to host transport layer, third is internet layer, and fourth is network access or link layer. Okay, so before we starting this topic TCP/IP protocol, so what is the difference between TCP/IP and OSI model? We have to study it first. So basically here you can see in the below. So in OSI model, there are presentation, session, then application. So in this TCP/IP model, a presentation and session layer is eliminated and only application layer is there. Then transport layer is there. Then physical and data link layers is also joined here and named as network access link layer. Okay, so these 3 layers are removed here. So there are only 4 layers which are left in TCP/IP model. So what is the difference between TCP/IP model here? So TCP refers to transmission control protocol, right? OSI refers to open systems interconnection. Open system interconnection. Then second is TCP/IP has 4 layers, right? Uh, you also see on the screen there are only 4 layers: process or application, host source or transport, internet layer, then network access or link layer, right? And OSI has 7 layers. TCP/IP is more reliable because it provides end-to-end connection, right? And it is secure and safe. So there is no error in data provided at receiver side, and also the data is error-free and confidential, and it is also identified that the data which receiver received is authenticated or the real one. No fake or false data is there, right? And OSI is less reliable because there are different layers, right? So TCP/IP doesn't have very strict boundaries, but OSI has strict boundaries, right? Like every layer has to do their respective task only, right? TCP/IP follow a horizontal approach, and OSI follows a vertical approach. So we can see the application layer, then it goes to session, then it goes to presentation, then transport, then data link, then network, then physical layer, right? So then again, when it the output or the desired request is fulfilled, then the result go back to again traversing all the 7 layers. Then at the end, at application layer, we got our data, right? So OSI follow a vertical approach like this, and TCP/IP follow the horizontal. TCP/IP use both session and presentation layer in application layer itself, and OSI uses a different session and presentation layers, right? TCP/IP developed a protocol and model. This is developed protocols, right? And OSI developed models than protocols. So the difference is TCP/IP is developed protocols only, and OSI developed models than a particular protocol. Transport layer in TCP/IP doesn't provide assurance delivery of packets, and in OSI, transport provides assurance delivery because it also deliver the acknowledges on the successful receive at on the successful receiving of data at receiver, right? So OSI is more reliable. OSI transport layer is more reliable here. Okay, so first one is network access layer. Network access layer is basically a combination of data link layer and the physical layer of the OSI model, and it look out for hardware addressing and protocol present in this layer allow for the physical transmission of data. So again, it just receive data, transform it into the bits, then into the frames in data link layer, add the MAC address, and then we just talk about the ARP being a protocol of internet layer, but there is a conflict about declaring it as a protocol of internet layer or network access layer. So it is described as residing in layer 3 and being encapsulated by layer 2. Basically both, right? So network access layer, there are different type of ARP protocols, and many other protocols are also working at the network access layer, which are studied later and described in ACN. Then second is internet layer. Internet layer is primarily the function of OSI network layer basically. Like exam name also describes this is basically a network layer because it defines the protocol which are responsible for logical transmission of data over the network. Logical transmission means IP, right? The main protocol residing at this layers are IP, Internet Protocol, responsible for delivering packet from source to destination or host to the destination by looking at the IP, like hope to hope delivery. To at every hope it checks the IP address, right? So IP has two versions, either IPv4 and IPv6, right? So IPv4 is the one of the most of the websites are currently using, but IPv6 is growing as the number of IPv4 addresses are limited in number than compared to the number of users. So we can also study it later classes IPv6 and IPv4 in detail. ICMP is Internet Control Message Protocol. It is encapsulated with the IP datagrams and is responsible for providing host with information about network problems. Okay. ARP stands for Address Resolution Protocol, and its job to find the hardware address of the host from a known IP address. So ARP has several types like reverse ARP, proxy ARP, and inverse ARP. So all these are studied later in detail. And the next one is host to host layer. Basically, it is kind of transport layer we can say because it is host to host delivery or host to host layer and responsible for end to end communication and error-free delivery of data. It shields the upper layer application from the complexities of data. So here, transmission control protocol, it is known to provide reliable and error-free communication between end systems. It performs sequencing and segmentation of data. As we already see, sequencing and segmentations are the major task of transport layer in OSI model. So this is the transport layer basically of the TCP/IP, and TCP/IP here is the main protocol, right? So it also has acknowledge feature and control the flow of the data through flow control mechanisms like go back and ARQ and many other algorithms are there in flow control, and it's very effective protocol but has a lot of overhead. Due to such features, increase overhead lead to increase the cost. So it is also in cost efficient. Okay, means the cost is high of TCP, and on the other hand, UDP uh, doesn't provide such features. It's like go-to protocol. If your application doesn't require reliable transport and you want it most effective, then go with UDP because unlike TCP, which is connection-oriented protocol, and UDP is connection-less protocol. In next lecture, we can study what is the connection-oriented protocol and the connection-less protocol meaning, right? So majorly TCP protocol is used, but UDP protocols are also used there in the applications where the company don't want to make it a authenticate or to say it's just transferring the data. Reliability feature is not there, right? And in next layer, which is application layer. Application layer is the layer perform the function of top three layers of the OSI model: application, presentation, and the session layer. It is responsible for node-to-node communication and control a user interface specification, UI specification. Some of the protocol present in the layer HTTP, HTTPS, FTP, TFTP, Telnet, SSH, SMTP, SNMP. These all are the protocols of email transfer, right? FTP, HTTPS, DHCP, DNS domain name server, right? Uh, Windows LPD. So have a look at the protocol in application layer for some information. Like majors are HTTP and HTTPS, Hypertext Transfer Protocol. It is used by the WWW, World Wide Web, to manage communication between the web browser and the server. So if we want to any request to the server, then we have to use like https uh, dot domain name, then .com or .edu or any kind of web address. Okay, then https stands for the secured version, right? It is a combination of http with ssl, secure socket layer, and it is efficient in cases where browser need to fill out the form, sign in, authentication, carry out bank transactions, right? So, like if we browse the sites by HTTPS, they are encrypted, but if we browse the sites by HTTP, they are not encrypted and not secure. So, browser also pop up the message that these sites are not secure for browsing, right? So, all these are basically the version of basically the mode of work and the difference between the HTTP and HTTPS. So HTTP provide less security and HTTPS provide the secure version, right? And the next is SSH. SSH stands for the secure shell. It is a terminal emulation software similar to Telnet, and the reason SSH is most preferred because its ability to maintain the encrypted connection. It set up a secure session over a TCP/IP connections, right? So SSH is also there. NTP works with network time protocol. It is used to synchronize the clock on a computer to one standard time source. It is very useful in situation like bank transactions. Like OTP is activate only for 10 seconds or 5 seconds. So the clock is there. After that, the session is timer. Okay, OTP is useless then. So this NTP work there. It is very useful in also like exams, right? In exam there is also a stopwatch or the watch start and end time is already decided there, right? So NTP is also working there. Suppose you carry out a transaction and your computer read at the time 2:30, while the server record it at 2:28 p.m. The server can crash very badly if it's out of sync. So it when you use NTP, it should be very important that the server is in sync with the application. Otherwise, it got crashed. Okay, so this is all about the TCP IP suite, right? Okay, so that's all for this class and the session. Thank you so much.